Hello students, today we will discuss a very important topic of mathematics, that is polynomial, and it is very much applicable in our day-to-day life. We are regularly using this concept of polynomial, but let's see how it is applicable. Suppose I am at my home and I want to go to school. I will book a cab, suppose a Ola cab I booked, and that started the journey from my home and take me to school, and automatically its meter give me the fare, that how much I have to pay. That is not predefined in that meter, but it gives you the exact value, that how much I have to pay from home to school. See how it works. For Ola, there are two kind of fares. One is fixed charge. Suppose that is rupees 5, and this much amount I have to pay for every ride, rupees 5. And the second one is variable charge. The second one is variable charge, rupees 10 per kilometer. Suppose this is rupees 10 per kilometer. Now the distance from my home to school, suppose this is x. So the total fare it comprises of this fixed charge and the variable charge, that is 10 rupees per kilometer, and the distance is x. So the total fare consists of this fixed charge 5 and the variable charge 10 into x. Let this total fare is y. Now for home to school, if this x is 5, the total fare will be equals to 5 plus 10 into 5. Instead of x, I have to use this 5, and this is 5, 10 into 5, 50, 55 rupees that I have to pay. But now consider that on the next day I will go from home to market, and here x is equals to 10. So I will use the same equation, the same algebraic expression, and at this time the total fare y is equals to 5 plus 10. Instead of this x, I will use the value 10. 10 into 10, 100, and the total fare will become 105 rupees. So what we are seeing, that the same equation is used many times, and this equation is a kind of polynomial. Next situation, like if this is a coordinate axis, this is our x-axis and this is our y-axis, and I will throw a ball at an angle theta. So the trajectory of this ball will be like this. Every time whenever we'll throw a ball at an angle, its trajectory means path, is like this, and this path is known as parabola. This path is known as parabola, and this parabola is represented by a type of polynomial equation, that is a quadratic equation. This parabola can be represented by a polynomial equation, and that is quadratic equation. So whenever we want to calculate the maximum height, the maximum distance, so we have to use an equation that is a quadratic equation, and that represents a parabola. So we can see that polynomial is applicable in our day-to-day life. Algebraic expression. As we have already learned this term last year, but I want to revise it. Suppose we have algebraic expression ax square bx plus c, then we will call this ax square as a term. This is a term. This bx is another term. This c is another term, and all the terms is having a variable and a constant value. Like in this term, this x square is a variable and this a is a constant. We will also call that a is coefficient of x square, b is coefficient of x, but everyone will say that this c didn't have any variable. It have a variable, but it is not visible, as we can write this c as c into x to the power 0, and the value of x to the power 0 is equals to 1. So this will become c into 1 or simply c. So this c is also having two terms, the c and a term that is x to the power 0, and this is not visible, but it exists in an algebraic expression. So how we can define that polynomial? What is a polynomial? Is every algebraic expression is a polynomial? Like I will write some algebraic expression: ax cube bx square cx plus d, x to the power 1 by 2 y to the power minus 1 by 2, x root x 1 upon root x, x plus 6x square. So all these are algebraic expression, because we have terms, we have variables, we have constants, everything. They all are algebraic expression, but the question is whether they all are a polynomial or not. So how we can say that algebraic expression is a polynomial or not? Then just look at the definition, a basic definition of a polynomial, that the polynomials are algebraic expression in which the power of variable is a whole number. Very important thing, just listen it carefully, that the power of the variable is always a whole number. So just look at the first example. Here we have variable x to the power 3, we have variable x square x, and obviously this is x to the power 0. So here the power is 3 and this is a whole number. Here the power is 2, this is also a whole number. Here the power is 1, this is also a whole number, and 0, obviously this is also a whole number. So this is a polynomial. In the second example, the power is 1 by 2. This is not a whole number, so this is not a polynomial. Again, root x, it means the power is 1 by 2. So this is also not a polynomial. Here the first variable x is having power 1 and the second variable is having the power 2. So 1 is also a whole number, 2 is also a whole number. So this is a polynomial. So students, just remember that the polynomials have the power, the variable have the power a whole number. It should not be a negative number. It should not be an irrational number. It must be a whole number. Whatever the power the variable carries, it must be a whole number. Degree of a polynomial. Every polynomial can be classified according to its degree. Now, what is the degree of a polynomial? It is the highest power of the variable. Every polynomial must contain a variable, and the highest power that the variable carry is the degree of that polynomial. For example, 6x square, 6x and 6. So here the variable is x, and obviously it is not written, but it is x to the power 0. So what is the power of this variable? 2. Here the power is 1, here the power is 0. So the highest power is 2. So what we will write, that the degree of this polynomial is 2. Another example, ax cube bx square cx plus d. Every term must contains a variable, and this d have a variable x to the power 0. So now just check the power of the variable. Here the power is 3, here the power is 2, here the power is 1, and here the power is 0. The highest power among the variable in this algebraic expression is 3, so its degree is 3. So just remember that the degree means the highest power of the variable, and according to the degree we can classify the polynomial as constant polynomial. For example, px is a polynomial, its value depends on x, and if I will write it as 5. Now we know that the 5 must contains a variable, that is x to the power 0. So here the degree is 0. Here the degree is 0, and according to constant polynomial, it is a polynomial whose degree is 0. So 5 is a constant polynomial. Pt, polynomial that depends on t, and if I will write 100, so here t to the power 0, it means 100 is also a constant polynomial. So whatever polynomial, if its degree is 0, we will call it constant polynomial. Next one is quadratic polynomial. Okay, before quadratic polynomial, we have to study about linear polynomial. Linear polynomial. A polynomial with degree 1. A polynomial with degree 1 is called a linear polynomial. For example, if I will write a polynomial px, this is equals to 6x plus 5. So here the degree of this polynomial, as the x is having a power of 1 and 5 with the variable x to the power 0, so its degree is 1. So this kind of polynomial is called a linear polynomial. Another example, let p t plus 8. Now the power of this t, variable t, is 1, and here 8 t to the power 0, so its degree is 1. So this is also a linear polynomial. Sometimes we call linear polynomial as linear expression also. We will call them as linear expression also. The next one is quadratic polynomial, a polynomial with the degree 2. A polynomial with degree 2 is called a quadratic polynomial. The standard expression, the standard form of a quadratic polynomial, we will write it as px, that is equals to ax square bx plus c. This is very important polynomial, quadratic polynomial, and here the power of this variable x is 2, the power of this x is 1, and for c the variable is x to the power 0. So degree is 2, obviously degree is 2, so this is a quadratic polynomial. So what is quadratic polynomial? Polynomial with degree 2. Another example, we will use the variable s this time. So 5s square 2s plus 1. Again this time we can see that the variable s is having power 2, this variable s has power 1, and obviously we will write s to the power 0. So degree is 2, and this is also example of quadratic polynomial. The last what we will study is cubic polynomial. Cubic polynomial, a polynomial with degree 3. And the standard equation for this kind of equation, a polynomial, is px, that is equals to ax cube bx square cx plus d. So what we will write with d, the variable, as x to the power 0. Now here the highest power is 3, so degree is 3. That's why this expression is called a cubic polynomial. Another example, let pt, that is equals to 6x cube, 5x square, 6x plus 9. Here the degree of this polynomial is 3, that's why we will call it a cubic polynomial. The next concept we will study about the value of a polynomial. Value of a polynomial. Value of a polynomial. Now, suppose we have a polynomial px, that is equals to 2x square, 3x plus 2. This is a polynomial and its value depends on x. So for x is equals to, we can consider any value, let it is 1. The value of this px at x equals to 1. P, instead of x I will write 1. Here also instead of x I will write 1. 3 into 1 plus 2. So this will become 2 plus 3 plus 2, that is 4 plus 3, 7. So the value of this polynomial at 1 is equals to 7. We can also find the value of this polynomial at x equals to minus 1. For that we have to put the value of x equals to minus 1 at here x. So it will become p minus 1, 2 minus 1. Instead of x I will write minus 1, a square, plus 3. Instead of x I will write again a minus 1 and 2. 2 minus 1 square is 1. 1 into 2 is 2. Minus 1 into 3, that is minus 3 plus 2, and 4 minus 3, that is equals to 1. So here this time the value of this px at x equals to minus 1 is equals to 1. So this is what the value of a polynomial is.